Hello everyone, welcome back. Let us start today. Public key crypto system. Okay, that is also called PKC and or asymmetric crypto system. First of all, why do we need public key crypto system? See, as I told you about the classical crypto system. See, classical crypto system, it can be broken if we reveal some encryption process or if we reveal some of the encryption technique, correct? So whole the symmetric key crypto system, the security is based on the secret key, but the classical crypto system, we cannot do that. Whereas if you take modern symmetric key, that is DES and AES, they follow the uh, Kerckhoff law, that is the security of their scheme lie on the hideness of the secret key, correct? The encryption and decryption, everything is publicly known, just secret key is the only thing which is hidden, correct? Now to execute this DES and AES, what you have to do, you have to first share the secret key with each other. Like you can do that in either a private meeting or through a secure channel. So there is no secure channel in which we can send the secret key. So what is the way we can share the secret keys? Because everything is going well, I can encrypt with the secret key, decrypt and so on, but I need to share a secret key among the two parties, say Alice and Bob. So the secret key should be, so one solution is we can use public key crypto system where we'll be using to share the secret keys, and then we'll be using a symmetric key for the encryption and decryption technique of the encryption of the messages, correct? So main idea, why we are using it only for keys exchange, because if you want to encrypt a message, the length, actually it is not efficient to do with PKC. It is very slow. Even if you see, we'll be coming to the security analysis also, why we don't use PKC for the encryption of messages or not, because first of all it is not efficient, and then the size of the keys will be size of the encryption, the cipher text, it will vary a lot, vary a large size, correct? So that is a problem. So let us start with the PKC. The concept of PKC was introduced by Diffie-Hellman in 1976. It was introduced by Diffie-Hellman in 1976 in their seminal paper New Directions in Cryptography. And this paper introduced the concept of PKC, how we can do to exchange the secret key. Okay, and later on, the security of, then they have given a Diffie-Hellman key exchange protocol. The security of that lie on the DLP problem. So we'll be seeing that in today's class. Okay. So for that, let us first quickly see what is one-way function. I had already told you in the last class what is one-way function. A function f from x to y is said to be one-way function if it is easy to compute f of a. A function f from x to y is said to be one-way function if it is easy to compute f of a, for each a belongs to x, for each a belongs to x. Okay, but it is very hard, but it is very hard, or you can say computationally infeasible. Computationally infeasible to determine the value of a, determine the value of a such that b is equal to f of a. That means finding the pre-image of b is hard. So that's why it is called one-way function. There is one more thing, that is trapdoor one-way function. See, a trapdoor one-way function is a one-way function with some secret information, which is called trapdoor. With the help of this information, hmm, anyone can find the pre-image, such that your f of a is b. Okay, for any given b in y. Okay. Now let us see what is the difference between symmetric key crypto system and public key. Although we have already done that in the distribution, in the PKC classification, but still we will be doing one more time little bit of that. What is the difference? Symmetric key crypto system versus public key. Which is also called asymmetric key. The first difference is the secret key. First is secret key. In the case of symmetric key, your encryption and decryption key are same. So here E is equal to D. But here what happens? E is not equal to D. That means I'll be having two keys here. One for E is our public key, and here D is my secret key. Whereas in this case your E and D both are actually it is only one thing which is secret. Second, the number of keys. Suppose I'm having n party. So if n user use the symmetric key, they need, let me just write number of keys for n user. See, if I'm having n user, so each user should have a key for everyone. That means each user, say A, B, C, suppose three people are there, so A should have a key, say KA, which is shared to this guy, shared to this guy, correct? So B also should have a key KB, which is shared to this guy, shared to this guy. C should have a key KC, which is shared with this guy and shared. That means each guy is having how many keys here? Three keys here, correct? one for this, one for communicating with this, one for communicating with this. And if you are having more number of people, so it changes actually. So actually it is the NC2, number of keys will be NC2. That is n into n minus 1 upon 2. So I had given you example of 3 people, so answer will be 3. Whereas in the case of public key, you just need to have n keys. Each party is going to have only one secret key with them. You don't have to have all the time new keys. Just n secret keys are required. Because the public key is available, just you need n secret key. Each party should have one key, secret key. And what is the cryptographic goal? So it provides three things: privacy, authentication, integrity. Privacy, authentication, and integrity. The symmetric key crypto system provides privacy, authentication, and integrity. But using asymmetric key crypto system, we can get non-repudiation also. We can get this privacy, or actually PIN, that shortcut we had written, PAIN. Privacy, authentication, integrity, and one more thing is non-repudiation. That means undeniable property. That means nobody can deny that I have not sent this or sent that. And if you talk about the encryption and decryption scheme, so let me see. Encryption or decryption technique. In the case of symmetric key, what happens? It is based on substitution or permutation of symmetric symbol. Substitution and permutation or transpositions of symbols and binary strings. Whereas in this case it is mathematical functions or number. Okay. Security. See, security of asymmetric key crypto system, that is public key crypto system, based on some hard mathematical problem. Whereas the security of symmetric key crypto system is because of confidentiality of secret key. That means secret key should be hidden. Okay, so now let us talk about what is Diffie-Hellman key exchange protocol. See, what is key exchange protocol? That means they want to exchange some key. The same key should be with both the people at last. That's why it is called key exchange protocol. Suppose Alice and Bob are two people we are talking about. So Alice and Bob agree on a large prime P and a generator G of Fp. So they have agreed on a large prime P and generator G for the group Fp. In general, actually G is chosen as primitive root. Primitive root modulo P. What do you mean by primitive root? Element which has say 0 is to P minus 1 equal to 1 mod P. So order of G should be P minus 1. In general, if you take n, then it should be phi of n. Order of G should be phi of n. That means there should not be anything less than that which has this order, which satisfy this equation. Okay. So now let us come to the algorithm. Let me write Alice here and Bob here. Okay. What do they have? They have a, they know a prime P and a generator G. This is what they know, and this is the group they are going to follow. Okay. So let us begin. First thing is Alice chooses E. Secret E. Secret means it won't be revealed to anyone. E, which is from 1 to P minus 2. This is what he chooses, and compute G raised to A, or let me just denote it as GA, which is G raised to A modulo P. This is what he computes. Okay, and similarly what Bob will do, he will choose a secret, say B, which again belongs to 1 to P minus 2, and he will compute GB. This is the notation I am using, which is G raised to B modulo P. So he is having GA, he is having GB, so they will exchange this value. So this GA, he will give the GA to Bob, correct, and Bob will give the value of GB to him. Okay, so after getting the value of GB, what he will do, he'll calculate the key. What is the key actually? GB the whole raised to A, and here this guy will calculate the key as GA. He got GA from him, and he will put a raised to B. So what is the key they will be getting? What is GB actually? It is G raised to B. So G raised to AB is the key. Here also he will get G raised to AB. So without sharing this without sharing this G raised to AB, they are able to get the key. This is the key they will be using. Correct? So the security of this algorithm lie on the DLP problem. That means given this GA and G, you cannot get this small a. This is what DLP problem is. So we'll be coming to it. And there is a problem with this scheme. Now this is what your Diffie-Hellman key exchange scheme is. It is very simple. The first guy chooses A secretly. This is his secret key, and he computes G raised to n and send it to the other guy. This guy secretly choose B and then compute G raised to B and send it to the other guy. Correct? What he will do, he will just calculate this and get the key. But there is a problem. There is a man in the middle attack. We'll just see what is this man in the middle attack. So what is man in the middle attack? Suppose Alice is here, Bob is here, there is a guy Malice, say who is adversary. He is the adversary. He is not the one Alice want to compute. He is not the one Bob want to do anything or communicate with him. Correct? So what he will do, again Alice is going to do the same thing. Alice will choose a secret A and he will compute this is the secret, and he will compute GA, which is G raised to A modulo P. Bob will again choose a secret B and he will compute GB, which is G raised to B modulo P. And what Alice will do, Alice will send it to the Bob. And suppose Malice is pretending that he is Bob. So what he will do, he will get this. He will get the value of GA from the Alice. But Alice don't know that he is communicating with Malice. He knows that he is communicating with Bob. Malice will pretend that he is Bob, so he'll be having this value. Similarly, Bob will send the message to Alice, but instead of reaching that information to Malice, it will be reached to the Malice. Bob won't be knowing that he's communicating with the Malice. He assumed that he's talking with Alice. So now Malice have the two things. He has G raised to A, he has G raised to B, correct? But still he cannot get the secret key A and B. But what he can do, he can choose a secret M and G raised to M, and he will send G raised to M to both of them. Let me call it as GM, which is G raised to M modulo P, correct? What he will do, he will send this G raised to M to Alice. He will send this G raised to M to Bob. Now Alice knows that Alice thinks that he's talking with Bob. So once he receives G raised to M, he will receive G raised to M. How will he compute key? The key for him will be GM raised to A. This is the key what he will be having, and this guy again he will be receiving this GM, which he assumes that he is getting from Malice, but Malice is in between who is giving this value GM. So the key will be what? It will be GM raised to B. But what do you observe? This GM is what? G raised to M. So it will be G raised to AM. This is the key, and here it is G raised to uh, BM. This is the key. So no, they don't have the same key, but Malice will have the same key. Malice will have a key to communicate with Alice. He will have a key to communicate with Bob. So because he is having G raised to A, G raised to B, both the thing, so he can compute G raised to A raised to M. He will get the key for Alice, that is G raised to AM. He is having G raised to B from Bob. He will put raised to M. He will be having G raised to BM. So now that's why it is called man in the middle attack, because a middle guy have the two keys, which he can communicate with Alice, pretending that he is the Bob, and G raised to BM, he can communicate with Bob pretending that he is Alice. So that's why it is called man in the middle attack. See, authentication, you can use authentication protocol to uh, 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 pretend this type of attack. That means you can put the hash value also, has you can reveal the hash value also with this, and that can be done. We will not be coming to that. Now let us see the security of this protocol. Before that, we'll be seeing some different problems. What are they? So first is computational Diffie-Hellman problem. Yeah, as we told you that security of any public key crypto system is based on some assumption, correct? So, and the security of Diffie-Hellman key exchange is based on computational Diffie-Hellman problem, Diffie-Hellman assumption, or CDH assumption. So let us first define what is CDH assumption. Computational Diffie-Hellman problem. So what is computational Diffie-Hellman problem? The secrecy of agreed shared key. The secrecy in the Diffie-Hellman key exchange depends on the computation of depends on the computation of g raised to ab g raised to ab modulo p given g raised to a and g raised to b. So if you are given with g raised to a, g raised to b, can you compute g raised to ab? So this is the problem, correct? This problem is called computational Diffie-Hellman problem or CDH problem. CDH problem. Given g raised to a, g raised to b, can you compute g raised to ab? Okay. And this next is DLP problem, that is discrete logarithm problem. The notation is DLP, we say DLP problem. Given a finite field fp, given a finite field fp, a generator G belongs to fp star, and an element H which belongs to fp star. To find a unique integer, a which is less than p, which is less than p, such that h equal to g raised to a modulo p. H equal to g raised to a modulo p. That means what? You are given with the value h, you are given with the value g, correct? This generator is known to you, this h is known to you. What is that you have to find? You have to find the value of a. This is what you have to find, correct? So such that h is equal to g raised to a modulo p. Why it is called discrete logarithm problem? See, a can be easily calculated if this mod p was not there, just taking log both the side. Log h is equal to e log g, and then I will just divide it. So why this is a hard problem? This is an intractable problem because I cannot take log both the side first of all, because I am running in modulo system. So after some time it will get reduced. If it is greater than p, then it will get reduced. So we cannot apply this, uh, we cannot take log and solve it. So it is called discrete logarithm problem. So the CDH problem and DL problem are two assumed intractable problems. The difficulty of these problem depends on the size of the problems. By size we mean the size of FP. If you take a large size of prime P, then even the choice of parameters also, the G and the private key. So these are the two problems, CDH problem and Diffie-Hellman. Sorry, discrete logarithm problem. The CDH problem and DL problem are two assumed to be intractable. Intractable. Intractable, we mean that you cannot get a polynomial time complexity to solve that. It is exponential. The difficulty of this problem depends on the size of the problem, on or we can say size of FP parameter that is G and private keys, that is A and B. So if you properly choose these parameters and the size of FP, then this is intractable. Okay. Now, yeah, but look at this one thing. It told that our security of Diffie-Hellman key exchange is based on CDS assumption. This is not based on the problem, CDS assumption. So let me just quickly define what is CDH assumption and DL assumption. If there does not exist, if there does not exist any probabilistic polynomial time algorithm to solve the given instance of Diffie-Hellman problem, given instance of CDH problem with non-negligible success probability, we say that Given instance of Diffie-Hellman problem satisfy CDS assumption. What is the assumption we are taking? That if there does not exist any probabilistic polynomial time algorithm to solve this CDH problem, and we call it as CDH assumption. Similarly, DL assumption. What is DL assumption? If there does not exist, there does not exist any probabilistic polynomial time algorithm to solve given instance of DLP. DLP or DL problem with non-negligible success probability. We say that given instance of DLP satisfy CDH assumption. We say that given instance of DLP satisfy DLP assumption. DL assumption, or I have not written DL assumption. Okay, now the question is, what is relation between this CDS assumption and DL assumption? See, it is clear that if you are able to solve the DLP problem, then we can easily get CDS problem, correct? An efficient algorithm that solves DLP will lead an efficient algorithm to solve CDH. An efficient algorithm that solves DLP will lead to efficient algorithm to solve CDH problem. So we can say that CDH problem is weaker than DLP. CDH problem is weaker than DLP. Okay, or CDS assumption is stronger than DL assumption. Okay, so the converse of this question is an open problem. Can DL assumption be true if CDS assumption is false? So this is the open problem. If CDS assumption is false. That means if you are able to solve the CDH problem, in probabilistic polynomial time, can you solve it, the DLP problem? Okay, so that's all. Thank you so much. Next class we'll be doing this RSA crypto system.